Bologna is one of the most widely consumed processed meats in the world, known for its smooth texture, uniform appearance, and mild flavor. Inside a factory, however, it is not just ground meat in a casing. It is a highly controlled food engineering process involving meat science, emulsification technology, heat treatment, and strict food safety systems. Here is a complete, detailed walkthrough of how bologna is made inside a modern industrial factory. Raw meat selection and receiving. The process begins with the arrival of raw meat materials at the processing facility. Depending on the product type and regional regulations, bologna may be made from a combination of beef trimmings, pork trimmings, chicken or turkey meat in some variations, fat trimmings from various cuts. These are not premium cuts of meat. Instead, they are carefully selected trimmings that still contain muscle protein, fat, and connective tissue suitable for processing. Before entering production, all meat is inspected for temperature control compliance must remain chilled, microbial safety, fat-to-lean ratio consistency, freshness, and odor quality. Only approved batches move forward into production. Trimming and pre-processing. Once inside the factory, meat is trimmed to remove excess sinew, large connective tissue pieces, hard cartilage, non-meat contaminants. The goal is not perfection in shape, but consistency in composition. Since bologna is a finely processed product, visible structure is not important at this stage. The trimmed meat is then cut into smaller chunks to prepare it for grinding. Temperature is carefully controlled throughout. Meat is kept near freezing levels to prevent bacterial growth and preserve protein structure. Grinding stage. The meat chunks are fed into industrial grinders. These machines reduce the meat into a coarse ground texture. This step is important because it creates a uniform particle size, helps later emulsification, improves mixing efficiency. Large-scale grinders may operate continuously, processing hundreds or thousands of kilograms per hour. At this stage, fat and lean meat are still separate but evenly distributed in the ground mixture. Formulation and ingredient mixing. This is where bologna becomes a scientifically engineered food product rather than just processed meat. The ground meat is transferred into large vacuum mixers or blending machines, where a precise formula is added. A typical bologna formulation includes meat base, beef or pork trimmings, fat content adjusted for texture and flavor, water or ice, added not only for moisture, but also to control temperature during processing. Salts, helps extract muscle proteins, which are essential for binding. Spices and flavoring agents, black pepper, garlic powder, onion powder, nutmeg or coriander, varies by region. Sugar or sweeteners in small amounts. Functional additives, food safe and regulated. Sodium nitrite for curing and color preservation. Phosphates to improve water binding and texture. Ascorbates to stabilize color and prevent oxidation. All ingredients must be measured with extreme precision. Even slight variations can affect texture, flavor, and safety. Emulsification process, key step. This is the most important step in bologna production and what gives it its signature smooth texture. The mixture is transferred into a high-speed bowl chopper or emulsifier. This machine rapidly cuts and blends meat into an extremely fine paste. During emulsification, meat proteins are broken down and activated. Fat particles are finely dispersed. Water is incorporated evenly. A stable protein-fat-water matrix is formed. Ice or chilled water is often added during this stage to prevent overheating. If the mixture gets too warm, fat separation can occur, ruining texture. The final result is a smooth, thick, homogeneous meat batter with no visible chunks. This is what differentiates bologna from coarsely ground sausages. Vacuum mixing and air removal. After emulsification, the meat batter is often transferred to vacuum mixers. Vacuum processing removes trapped air, which is important because air bubbles can cause texture defects. Oxygen can accelerate spoilage. Color stability improves without oxygen exposure. The mixture becomes dense, uniform, and ready for stuffing. Stuffing into casings. The emulsified meat mixture is pumped into casings using high-pressure filling machines. Casings can be natural casings, rare for bologna, collagen casings, common. Synthetic cellulose casings, most common for industrial bologna. The machine ensures uniform diameter, consistent filling pressure, no air pockets inside the product. The result is long cylindrical logs of raw bologna mixture sealed inside casings. These logs can vary in size depending on final product specifications. Linking and shaping. Once filled, the long bologna logs are twisted or clipped into smaller sections. Industrial machines divide them into individual sausage-sized units, large deli-style logs. Each segment is sealed tightly to prevent leakage during cooking. At this stage, the product is still raw and must be cooked before it becomes safe to eat. Thermal processing, cooking and smoking. The filled bologna is transferred into large cooking chambers called smokehouses or thermal ovens. This is a critical safety step. The cooking process typically involves controlled stages. Drying phase, low heat begins to remove surface moisture. Cooking phase, internal temperature is gradually raised until the product reaches a safe core temperature. This ensures the destruction of harmful bacteria. Smoking phase, optional depending on product. Some bologna varieties are exposed to wood smoke to add flavor and color. The entire process is tightly controlled with sensors monitoring internal temperature, humidity levels, cooking duration, air circulation. The goal is even heat penetration throughout the product. Cooling process. After cooking, bologna is rapidly cooled. This is essential for food safety and texture stabilization. Cooling is done using cold water showers, air chilling systems, refrigerated rooms. Rapid cooling prevents bacterial growth and helps maintain product firmness. It also locks in the final texture, making it easier to slice. Casing removal and surface treatment. Once cooled, the outer casing is removed if the product is meant for deli slicing. The surface is inspected for color uniformity, texture consistency, absence of defects or air pockets. Some products may be lightly smoked or surface treated again for appearance enhancement. Slicing and portioning. For retail and deli products, bologna is sliced into uniform rounds using high-speed slicing machines. These machines ensure consistent slice thickness, clean edges without tearing, high-speed continuous output. Slices may be stacked into packs or rolled for packaging, depending on product type. Large logs may also be shipped whole for deli counters. Quality control and safety testing. Food safety is a major priority in bologna production. Every batch undergoes strict testing, including microbiological analysis, fat content verification, moisture balance checks, pH level measurement, flavor consistency testing. Metal detectors and X-ray systems scan final products to ensure no foreign materials are present. Only batches that pass all standards are approved for packaging. Packaging process. Packaging depends on the product form. For sliced bologna, slices are stacked into trays or vacuum packs. Air is removed to extend shelf life. Packages are sealed airtight. Labels and nutritional information are applied. For whole logs, vacuum-sealed plastic wrapping, protective outer packaging, batch codes for traceability. Packaging is designed to extend freshness, prevent contamination, maintain moisture balance, ensure easy transport, cold storage and distribution. Final products are stored in refrigerated warehouses to maintain safety and quality. Temperature is strictly controlled throughout storage and transportation. From warehouses, bologna is distributed through cold chain logistics, refrigerated trucks, distribution hubs, retail stores, and supermarkets. Maintaining cold conditions is essential to prevent spoilage and ensure product safety. Final summary. Bologna production is a highly engineered food manufacturing process that transforms raw meat trimmings into a uniform, smooth, and stable product. It involves careful meat selection and trimming, grinding and emulsification into a fine paste, precise blending of spices and additives, high-pressure stuffing into casings, controlled cooking and smoking, rapid cooling for safety, automated slicing and packaging. What looks like a simple lunch meat is actually the result of advanced food science, industrial machinery, and strict safety controls working together continuously inside a modern factory.